Hey guys, Mr. Milton here. Today we're going to look at triangle inequality notes. At the end of this video, you should be able to list the angles and sides of a triangle in order, and you should be able to determine the possible side lengths of a triangle. So here are the theorems that we're going to deal with today. One concerning sides and one concerning angles. So this first one, it says if two sides of a triangle are not congruent, then the larger angle lies opposite the larger side. Okay, and so here we're going to list angles in order from least to greatest. And here's how we do it. So again, least to greatest, that means I want to find the smallest angle. So in order to find the smallest angle, I'm going to look for the smallest side. My smallest side is 2.7. Which angle opens up to that side? M. Angle M will be the least or the smallest angle. The second smallest angle will be across from the second smallest side. KM is smaller, 4.3 is smaller than 5.8, so the angle that opens up to 4.3, angle L. Okay, and then the one that's left, angle K. So the smallest angle is across from the smallest side. The largest angle is across from the largest side. I want you to notice that you can only sort these angles. You cannot find the actual measure of each angle just based off of this information. Okay, you can only short it. I can only say, hey, K has to be the biggest one because LM is the biggest side. But it's not like I can say K is 67 degrees because we got 5.8. Okay. All right. Another example, you might have it set up more like this. In triangle PHT, anytime you are given a scenario like this, it is a good idea to draw the triangle out. Triangle PHT, PH is 16, TP is 20, TH is 13. List the angles in order from largest to smallest. So from largest to smallest, always make sure that you read the directions so that you do what the problem says. Largest to smallest, the largest side is across from the largest angle. So H is the largest, 16, T should be second, and P is after that. Okay, all right, next theorem. Theorem 2 says if two angles of a triangle are not congruent, so now we're talking about angles and not sides, then the larger angle lies opposite the larger side. Okay, basically the same thing. We're looking at it from the same way. So now we're going to list the sides in order from smallest to largest. So this triangle, first of all, we can't start unless we know all of our angles. So we have 45 and 75 for angle O and angle N. And so we can find angle M, 110, 120, 180 minus 120 leaves us with 60. So we're listing these sides from smallest to largest. Well, the smallest angle is O. That means the smallest side should be MN. Second smallest angle is 60, angle M, so ON. Largest side is MO because the largest angle is N. Okay, so pretty simple, straightforward there. Back side. List the sides of triangle DVQ in order from longest to shortest. So we have triangle DVQ. Like I said, always a good idea to draw a triangle out. Angle D, they say, was 51. Angle V is 4x plus 3. Angle Q is 5x minus 18. All right. And so this problem adds a little bit of algebra to it, but nothing that we can't handle. We know that all these together should equal 180.
And so we can find out 180 minus 51 gives us 129. So there's 129 degrees left to split between 4x plus 3, angle V, and 5x minus 18, angle Q. So we have 9x minus 15 equals 129, and that means 9x will equal 144. All right with that? Yep. 144. And then divide by 9, and that'll give us 16. So x is 16. That'll help us out because this is 64 then plus 67. Okay. And then this will be 80 minus 18, which is 62. All right. So we know that angle V is 67 degrees, angle Q 62 degrees, and so now we can list these from longest to shortest sides. So the longest sides across from the largest angle, DQ. Second largest side, BD. The shortest side, BQ. Okay, and that's all from just saying smallest side, smallest angle. Largest side, largest angle. All right. Make sure this is set correctly. All right. So now, this problem says which side is the shortest in the diagram. So here's how we're going to do this. This triangle's 30. Since they're asking us about sides, angles are the important part. This is 30. It's an isosceles triangle. So we have 150 to split between these two. That means both of these angles are 75. So we see that QR in this triangle, QR is the shortest side. Okay, so this is the shortest side here. Alright, now in this triangle, QRS, this is 40, this is 90, this is then 50 degrees, right? Because 90 plus 40 is 130, 180 minus 130 is 50. So angle S is 50. So looking at this triangle, we see that the shortest side of this triangle, the smallest angle is angle Q, or RQS, so the shortest side has to be RS. RS is the shortest side here, and that is shorter than the shorter side of the other triangle, so RS is the shortest side. A little bit of thinking, but got it through. Okay, and now we're going to talk about the inequalities that happen in triangles. Okay, and the triangle inequality theorem says the sum of the lengths of any two sides, so when you add two sides together, is always greater than the length of the third side. Okay, greater than, not greater than or equal to, just greater than the length of the third side. So what that says is A plus B, these two sides, has to be more than C. A plus C, these two sides, has to be more than B. B plus C has to be more than A. And so here are some problems that you'll see dealing with this theorem. It says, can a triangle have the side lengths 4, 6, and 9? So we could set up this inequality and say, hey, 4 plus 6, is that greater than 9? Yes. Hey, 4 plus 9, is that greater than 6? Yes. Hey, 6 plus 9, is that greater than 4? Yes. Okay, so can a triangle have these side lengths? Yes. If any one of these is no, then the answer is no. Now, that's the way that you could do it if you want to do all three of those. The short way, and I'll just say shortcut, kind of a shortcut, you add the two smaller sides together. If the two smaller sides are bigger than the larger side, then it works out. So for B, instead of doing all three of these, we could say, well, is 3 plus 7, smaller two sides, greater than 12? No. 3 plus 7 is 10, it's not greater than 12. If we did all of it, we'd say, okay, is 12 plus 3 greater than 7? Well, obviously, because 12 is greater than 7. Is 12 plus 7 greater than 3? Well, obviously, because 12 is greater than 3. Okay, or 3 is greater, 7 is greater than 3 as well. So these two have to work. Check the smaller two sides and see if it's greater than the third. Remember, only one of them isn't going to work. Okay. All right, for C, we have 5 plus 5 greater than 10. Is that true? No, it's not true. So it won't work. We could do that again, or we could do 5 plus 10 greater than 5, obviously. 10 plus 5 greater than 5, obviously. Okay, but it does not work. Remember, it has to be greater than, not equal to. Okay, and now with problems that say find all the possible lengths of the third side. Okay, now all the possible lengths means that we're going to have multiple answers. So we're going to have an inequality, not just the equals. I'm not going to ask you to say like 1 and 2 and 1.1 and 1.2 and all those things. All the possible sides, we're going to list them as an inequality. And this is how we do the inequality. We basically have a compound inequality. And this is what our compound is going to be. We need our number to be less than these two added together. Okay, so we know that x has to be less than 7 plus 9. And it has to be more than the difference of these two, because when I add it to 7, it has to be more than 9. So it has to be more than 9 minus 7. So x has to be greater than 2 and less than 16. Okay. My last one, if I want to find the possible side, I'll just use y. Remember that y has to be less than these two added together, 37, and greater than the difference between these two, 9. And so that's my inequality. These are all the possible lengths for y, somewhere between these two. Okay. All right, so we talked about ordering largest sides and angles in a triangle based off of their given sides or angles. We've talked about the triangle inequality theorem, and we've solved a couple problems using that. All right, see ya.